In single-pass system, the seawater feed supply is pumped through cartridge filters by a low-pressure booster or feed pump. Pre-treatment of the feed water is essential in order to minimize fouling of the membranes. A chemical dosing system ensures that the feed water is satisfactorily treated before it comes in contact with the membranes. After the filters, the flow passes through the high-pressure pump and then to the membrane stack. The permeate is then filtered and sterilized and pumped to the storage tank. The salt concentrate is drained out from the membrane stack. The double-path arrangement is identical to the single-path system, except that the permeate from the first pass is used as the feed for the second pass. Permeate from the double pass is of very good quality, with a low total dissolved solids or TDS content. The concentrate from the double pass is also of very high quality and is used to dilute the original seawater feed. Complex double pass system can produce water of about 10 ppm. A further advantage of this double pass system is that in case of failure of one stage, the unit can continue to produce water, although the product will be of lower quality. Osmosis is the natural tendency of two fluids separated by membrane to equalize salt concentrations. It has two regions, A and B. A has a fresh water of lower concentration and B has seawater of higher concentration. It has a semi-permeable membrane C with a dense barrier layer. The membrane has small pores which allow the water to pass through. The flow from lower concentration to higher concentration through semi-permeable membrane continues to take place till the head of the water in the higher concentration side increases to such a value that it arrests the flow through semi-permeable membrane. This pressure is the osmotic pressure. Ships use the reverse osmosis method to desalinate and purify salty seawater of higher concentration. This process is exactly the opposite of osmosis. In this process, an external force is given on the surface of the liquid of higher concentration. B has seawater of higher concentration, while A has fresh water of lower concentration. When pressure is applied externally on the side of the membrane, where the chemical concentration is highest, the water molecules are forced to move from the region B to A through a semi-permeable membrane. During this process, the salts are trapped inside the membrane. The flow rate through the membrane is controlled by membrane thickness. The water that does not pass through the membrane has salts of higher concentration. The permeate enters region A and the concentrate is left out in region B.